Hello students, welcome to lecture of Kinematics and Theory of Machine, and we are going to continue our chapter gears. And in this lecture we will solve the example based on the interference in the gear, okay, which will be our last lecture of this chapter. Okay, let's start so you can see the given data here. A pair of involute gear with a 16 pressure angle, pitch of module 6 mm in a mesh, number of teeth in a pinion is a 16, rotational speed is a 240 rpm when the gear ratio is equal to 1.75. Gear ratio is given 1.75. In order that interference just avoided, means interference is avoided, find the addenda on pinion and gear wheel, length of path of contact, and third point is the velocity of sliding teeth on each side of pitch point. Okay, so these three data is asked. First of all, we have to understand that interference is just avoided. It means that we have to use the formula which is based on minimum number of teeth to avoid the interference, because interference is just avoided because at that point length of path of contact will be maximum, and it will be not KL, it will be the M to N point, and it is also, we have discussed in our last theory, it is a minimum number of teeth to avoid the interference. Okay, let's start. So this is the given data. Phi is given 16, M is a 6 mm, and RPM of pinion is given, which is the N1, 240 rpm, and teeth is a 16, so T is a 16, and gear ratio is equal to capital T by small t, 1.75. okay, so 1.75. using this formula, because we know that the gear ratio is equal to ratio of the teeth or ratio of the velocity, so you can find the RPM of gear 2 using this gear ratio also, and you can find the capital T. Okay, you can find the capital T also, because you already know the 1.75 is a gear ratio and a small t is a 16, so you can find the capital T here also. So using this RPM 240, you can find the omega 1, because omega 1, angular velocity of pinion, is equal to 2 pi n1 by 60. Okay, so what will happen? 2 pi n is a 240 by 60, and answer will be 25.13.6 radian per second. Don't forget the unit, radian per second. And same as you can find the capital T here, so it will be 28, because capital T is equal to G into small t, and answer is 18. So now capital T and small t are known and omega 1 is known. Now we are going to start the addenda or addendum for the pinion and gear. Okay, for that I will use these two equations. Okay, check this out. Addendum of pinion is equal to mt by 2. So this equation is already we have seen one time during the derivation of minimum number of teeth, but I will revise again how it is useful in our this example. Okay, so you must know the minimum number of teeth to avoid the interference, and what is the addendum and what is the fraction. Okay, let's start. So I will use these two formula in example. Okay, so this is the formula I am using for the example. It is already discussed in theory, but I will revise it again. Let's check it out. Okay, so first of all, we know that this is the minimum number of teeth to avoid the interference in a wheel. Okay, and in this you know that AW, what is AW, capital AW? Okay, so first of all we must know that addendum radius, always addendum radius is equal to what is pitch radius plus addendum. I am giving you an example and I am saying that small t, and in a derivation of minimum number of teeth, we have derived that, we have assumed that this A addendum is always fraction of m. I am saying that like this A is given sometimes 10 mm and module m is equal to given 5 mm. So what is given during the example, if module is a 5 mm, they will say addendum is equal to 2 module. 2 module means one module is equal to 5 mm. So our answer will be ultimately this 10 mm. 10 mm. But always this addendum is given in a form of module. So I am saying that if A is given as a 1 module, 2 module, and now the answer of this A addendum is depend upon the module. If module is a 7, then our addendum is equal to 7, or in this case 14. So this fraction is we have assumed as a capital AW. Remember that, capital AW. So now we want the addendum. What will be the addendum? Addendum is equal to module into AW. So we want the addendum here. We want to find the addendum. So what we will do? We are going to subject this AW in this formula, and after that we will multiply with the AW into m. So we will find the addendum here. Okay, let's start. So AW is equal to, we are going to subject this AW, making the subject capital AW. So this is going to multiply here and divide by 2. So T by capital T by 2 into this. Now what is the addendum? Addendum is equal to module into capital A into W. So we are going to multiply m on both sides, here and here. So this formula will be like this, and addendum of will is equal to capital AW into m, or you can write this m into capital T by 2 under root, and in this formula small t by capital T, you can write this 1 by G. Small t by capital T, 1 by G. Here you can write this here 1 by divide by G, same as here 1 by G. Both formula can be used. Okay, depend on what is given in data. So this formula is for directly addendum. Okay, so we have to find the addendum. This is the formula, m small t by 2, and we have the gear ratio also. Now put all the data, like a module is given 6 mm. Okay, small t is a 16 mm is given. Okay, and phi is given 16. So phi is given 16. So we put all the data, and you will simply find the addendum, which is 10.76. Okay, 10.76 addendum of the pinion, and you know that the same formula can be used for the wheel. Okay, same type of formula is there. So we will find for the wheel m capital T by 2, and putting all the value, you will find the addendum for the pinion and wheel. Okay, it is very useful. We will use this data in our further derivations. Okay, let's start. So first of all, now up to this point our example is new. Now same procedure will be followed, like KP, PL, KP plus PL, arc, contact ratio, angle turned by the pinion, all other data can be asked, because this is the new portion in interference. Okay, and after that, like all example will be same, like find the KP plus PL, find the arc, find the contact ratio, find the angle turned by the pinion, find the maximum velocity. Okay, so this type of data can be asked, but up to this point, after that will be always same procedure will be followed. Okay, like we have to find the length of path of contact. For that, first of all, we take the data we have found it earlier, like addendum of pinion and wheel. Now you are going to find the pitch circle radius for pinion and wheel, addendum radius for pinion and wheel, and then KP and PL. So You know that capital R is equal to M capital T by 2, 84. Now small r is equal to M small t by 2, and small t is already found at 16, so 48. Now addendum radius for the wheel and addendum radius for the pinion. So these all 4 radius must find always. Okay. After that, now you are going to find the length of path of contact Kp, and it is a 26.45. After that, same will be for PL, because all small r is already finded like this. Small ra is equal to here 52 and small r is equal to 48. So you will put all data in that and you will find the PL path of recess, which is 11.94. And what is a Kp plus PL is equal to KL, length of path of contact, and it is a 38. Okay. So always remember that minimum number of teeth. That equation is very important. If you make any mistake in that formula, your total answer will be wrong, because you have find it this is, if you mistake any in this data, your this answer will be wrong. Okay. Now we have the Kp and PL. Now this is the third point we have to find in this: maximum velocity of sliding of teeth either side of each point. Either side means left and right. Left means point of engagement KL. Right side means up to L point, like PL, pitch point to L point, PL. So sliding velocity we have divided into sliding velocity at a approach and sliding velocity at a recess. So same method will be applied, but what is the formula? Omega 1 plus omega 2 into Kp, and second is the omega 1 plus omega 2 into PL. So first of all, we have to find the omega 1 and omega 2 both. We have given omega 1 is here. Omega 1 is equal to 25.136. But using gear ratio, we will find the omega 2. Okay. So omega 1 is given 25, but omega 1 upon omega 2, which is a gear ratio, capital D by small t, 1.75. So you can find the omega 2, which is the 14.28. Okay, using the gear ratio, because gear ratio is a ratio of the teeth and also speed, you know that, in inversely. So if you say that, so now you are going to find the sliding velocity on both sides. First of all, find the sliding velocity, maximum velocity of sliding on teeth on the left side, means approach. So we will multiply omega 1 plus omega 2 into Kp in this case. And after that, if you want to find the maximum velocity of sliding on the right side means, you know that upside, upper side, P, K, P and then L, it is the right side. So omega 1 plus omega 2 into PL. Okay. So we have already finded the value of PL here. You know that PL is already finded. We will put in this value, and omega 1 and omega 2. Omega 1 is a 25 and omega 2 is equal to 14.28. So you will put this value and you will find the omega 1 plus omega 2 into PL 471 mm per second. Okay. So that's it. It is the example of interference.